All right. Again, good morning, everybody. So, how was the problem set? So, I hope you had fun answering the problem set. Um, I was able to grade probably around 5 papers so far out of ilan ba kayo? I think there's 24 of you tapos ilang submission bins yon. So medyo I have a long way to go. Expect that I'll be a little bit slower in grading your papers now kasi sabay-sabay na. Yung 174 tapos 151. Medyo maraming dapat i-grade so I'll just take my time and grade them. Ano? So, pero rest assured, probably in 2 weeks' time, you'll get your complete feedback on your midterm exam. Okay. And then now start preparing for the pre-final exam. The pre-final exam is envisioned to be face-to-face. Ano? So, ganun uli, barring any extraordinary circumstance like the very big typhoon that we encountered. So, magpupush yung ating pre-final exam face-to-face. Okay? And then I guess last time we stopped here at solving homogeneous general linear differential equations. And what we learned is that the solutions really basically boils down to to the zeros or the roots of your auxiliary polynomial. So nakita natin ano yung nangyayari kapag meron kang case 1, meron kang distinct na mga roots. Kapag meron kang mga distinct na mga roots, so linear combination lang ng e to the roots times x yung ating solution, right? So kunin mo lamang yung roots r sub I of your auxiliary equation or your auxiliary polynomial or your what we call the characteristic polynomial, kunin mo yung linear combination ng mga e to the roots times x. So that's going to be your general solution to the homogeneous GLDE. Now, if there are repeated roots, so halimbawa si si r ay root of multiplicity k. Diba? Ito ay root of multiplicity k. So, ibig sabihin, k times naging factor ng auxiliary polynomial, yung x minus r. Then, ang ating solution ay polynomial of degree k minus 1 times e to the rx. Or whatever your independent variable is. So, that's case number 2. And then case number 3 ay paano kapag meron kang complex roots. And nakita natin from last time, kapag meron kang complex roots, a plus or minus ib, all right? Kasi one main takeaway that we got last time, if a plus ib is a root of your polynomial, then a theorem in algebra tells us that a minus ib, the conjugate of the first root, is also a root. So complex roots always comes in pair. Hindi pwedeng si a plus ib lamang yung root. Kasi kapag si a plus ib ay root, na-prove sa algebra na yung a minus ib ay root din. Okay? So kapag meron kang mga roots na a plus or minus ib, ito yung makukuha mong general solution from that. You have a linear combination of e to the ax. So a is the real part of your complex number. Then the imaginary part becomes the argument of your trigonometric function. So e to the ax times cosine of the imaginary part times x plus d2 arbitrary constant times e to the real part times x times sine of the imaginary part. Okay? So just to quickly finish this up, I know you might have nag-advance reading ba kayo? Kasi hindi natin to natapos last week, no? Tapos supposedly kasama siya sa coverage ng midterm exam. Did you guys try to read the rest of the modules, the slides, so we can just skip this? Or gusto nyong i-discuss pa rin sila, even in a medyo mabilisang manner? Anong ginawa nyo, guys? Okay, so may request si Kiefer, i-discuss pa rin. Okay, that's okay. Though, madadaanan pa rin natin ito when we go to this next section, all right? So kaya medyo mabilisan, pasada lang, ano. But of course, we will not sacrifice the rigor. But yeah, okay. So those are the suggestions I got. So let's still discuss this, ano. So, but I hope the first two cases are clear to you. Okay? Sana clear siya. So ngayon tingnan natin. Again, kapag ka meron kang homogeneous GLDE, kailangan kunin mo yung auxiliary equation o yung characteristic polynomial. So the characteristic polynomial. So now I'm shifting between characteristic polynomial and auxiliary polynomial. They are all the same thing. Depende lang sa author kung ano yung ginagamit. Sa atin, auxiliary with an LIA yung, yung ginamit. Pero usually ang auxiliary ni-spell ko as double L. Tapos kapag GLDEs, usually ang tawag ko ay characteristic polynomial. So it's just semantics, pero they all mean the same thing. So the characteristic polynomial here is m squared minus 2m plus 5. Okay? So, or maybe instead of characteristic polynomial, sabihin ko ay characteristic equation para pwede kong i-equate sa 0. So yung characteristic equation natin ay m squared minus 2m plus 5 ay quadratic function. All right? And then solution sa quadratic equations, gusto nating mag-factor. Kaya lang, the only factors of 5 are 5 and 1. So there's no way that we can get a middle term that is equal to negative 2m. Kasi either I get a 6m or a 4m lamang. Pag kinuha ko yung possible sums ni 5 and 1, nakatangi-tanging factors ng 5. So that means simple factoring will not work here. So what I'll do is I'll use the quadratic formula. Okay? So pag nag-quadratic formula ko rito, remember m equals negative b plus or minus radical b squared minus 4ac all over 2a. Ito yung quadratic formula where a is positive 1, b is negative 2, and c is equal to 5. Okay? So plug mo yan sa quadratic formula. So we'll get negative b. So that's going to be a positive 2 plus or minus radical b squared minus 4ac. Tama ba? Negative b plus or minus b squared minus 4ac all over 2a. Okay, so this will be 2 plus or minus, I'll have 4 minus 20, so that's square root ng negative 16 all over 2. And here's why I know that meron tong imaginary root. Kasi nagkaroon tayo ng square root ng negative 16. So hindi natin to sasabihin na there exists no solution because we allow the solutions to be imaginary numbers. All right. So we further simplify this to 2 plus or minus. Remember, the imaginary unit I is a number such that I squared is negative 1. So yung square root of negative 16, pwede kong isulat as square root ng negative 1 times 16. So konting complex review ng complex numbers. Ano? So pwede kong i-factor yung negative 16 dun sa radicand as negative 1 times 16. Tapos gagamitin ko yung fact na ang I squared ay equal kay negative 1. So the negative 1 inside the radical will be replaced by I squared times 16. Square root ng I squared ay I. Square root ng 16 ay 4. So essentially, negative square root of 16, square root of negative 16 is actually 4i divided by 2. All right? And then we can simplify. We can factor 2 out of the numerator, cancel it with the 2 in the denominator, which will give us the roots 1 plus or minus 2i. Right? So the real part here, ang real part dito ay 1 at ang imaginary part ay plus or minus 2i. Oh, sorry, ang b natin dito ay, ang imaginary part ay 2. If we follow the conventions that we have before, kasi sabi natin kanina, dun sa case number 3, ang case natin doon, ang complex roots ay a plus or minus bi. Dahil dito na-compute natin na root ay 1 plus or minus 2i, so a equals 1 and b is equal to 2. So therefore, the general solution to the GLDE, to the homogeneous GLDE, is a linear combination of the form constant times e to the ax, so e to the 1x, times cosine ng bx plus constant e to the ax times sine ng bx. Okay, this is the general solution. All right, or you can write it as e to the power x times a cosine ng 2x plus b sine ng 2x. So expect nyo na, kapag ka meron kang real roots, magkakaroon ng sine and cosines doon sa inyong solution. If you're a little bit doubtful of your answer, just plug this into y here. And then dapat pag pinerform mo yung operator, dapat ang sagot ay 0 to double check if your answer is correct. Okay? Okay, any questions? Is that okay? So, ito yung process kapag ka meron kang complex roots doon sa yung characteristic polynomial. Alright? Ito yung medyo kakaiba, no? Kasi merong konting complex numbers. But I hope in this example, you recalled how to solve the roots of a characteristic equation, especially if the roots are complex, and what to do with that complex solution. Okay? Perhaps let's consider another one. D squared minus 4d plus 7 applied to y is equal to 0. GLDE ulito. So, kukunin natin yung characteristic equation. So I guess in this example, just to save some time, kasi medyo week 11 na nga pala tayo, so malapit-lapit na rin tayo dun sa dulo. So I need to pick the pace a little bit up. So siguro in some of the examples, especially kung pangalawa or pangatlong example na yan, I will not too formal in writing my solution. So what I'll be writing instead of a full solution that I would like you guys to write, I'll just have a sketch of the solution. Okay? Yung mga words, yung mga paragraphs, sasabihin ko na lang verbally. So hindi ko na siya isusulat katulad nung ginawa ko kanina. So I hope that's okay. But I want you to build a practice na kapag ka nagsosolve kayo, you make it nice to read so that yung nag-check ay medyo masasayahan habang nagbabasa ng solution nyo. So don't be shy putting in words or sentences into your solution, especially if you're introducing new variables, if you're using a trick, kindly put them into writing so that madaling sundan nung babasa yung inyong solution. All right? Meron akong excuse to be not too detailed in my solutions kasi nandito ako sa harap nyo or virtually. Tapos I am speaking out kung ano yung ginagawa ko. So just turn all of those words that I'm saying into letters, into written words. So yun yung magiging solution. Okay? Okay lang ba yun? I hope that's fine. Yun na lang yung compromise natin para mabilis ko matapos itong section 3.5. So first, let's take note of what the characteristic equation is. So write this down. Dapat pala nagano ko, no? Text to voice, voice to text conversion. Pero anyway, so the first step in the solution is to take note of the characteristic equation. In this particular case, our characteristic equation is m squared minus 4m plus 7 equals 0. So really what we are just doing here is to replace all of the operators d in our operator by a constant, by an indeterminate m. Okay? Palitan ko lang lahat ng capital D by m, equate ko sa 0, I'll get the characteristic equation, and then I'll solve the roots of the characteristic equation. Luckily, 7 is prime, so ang factors niya lang ay 7 and 1. So ano lang yung mga possible middle terms na makukuha ko? Pag-adding ko lang siya, so I'll have plus or minus 8. Or isubtract ko siya, I'll get plus or minus 6. Pero ang target natin ay negative 4m, I cannot get it using the usual factoring technique. So that tells me, siguro mas madali rito mag-quadratic formula. Applying the quadratic formula gives us the following solution. It's going to be 4 plus or minus square root ng 16 minus 4 AC all over 2a. So that's 4 plus or minus, what? We'll have 28. So 16 minus 28, so that's negative 12 over 20 over 2. And this is 4 plus or minus. I have an I to get rid of the negative sign inside the radicand. So pag lumabas yun, I na. And then yung 12, pwede ko siyang isulat as what? 2 square root of 3 all over 2. So basically, our solution m to the characteristic equation is 2 plus or minus square root of 3i. All good? I guess ito yung pinakamatrabaho. Ito yung pinakamahirap gawin dito. I-solve yung characteristic equation. But is my solution correct? Or is this clear? Okay, can I see some reactions? Thank you, guys. So 2 plus or minus 3i. So ibig sabihin, ang a natin, which is the real part of the solution, is 2. And b would be the absolute value of the imaginary parts of the solutions. So this is root 3. Okay. So yan lang yung gagamitin natin dun sa pagbibuild ng general solution dun sa GLDE. So therefore, the general solution sa ating GLDE ay e to the ax. So it's going to be e to the 2x times linear combination ng cosine ng bx plus multiple ng sine bx. Okay, so that's our solution. Easy, right? Ang dali niyang i-assemble basta na-solve mo na yung characteristic equation. Okay? But of course, this case goes hand in hand and in conjunction with yung unang dalawang cases na na-consider na natin before. I hope the next example will show us that. But before I change slides, any questions? Sana ganito lang pala yung mga nasa problem set, no? Hindi pala ako nagpa-react dun sa problem set. Gawin ko siguro yung susunod na homework kay reaction video nyo dun sa problem set, dun sa midterm exam. That should be fun. Gusto nyo ba? Katuwaan lang, So, sige, yun na lang. Yun na lang yung homework nyo. Next homework. I'll send the details later, but let's do a reaction video on the problem set. Medyo matatagalan pa pag reaction video dun sa reaction video dun sa score nyo, So, mas masaya sana yung kaya lang medyo matatagalan pa ako matapos yung pag-grade ng problem set. Siguro, reaction video, maybe how you felt about the problem set, what you think about it, what are the what's the most challenging question, what's the greatest difficulty that you encountered. So siguro mga ganun. It could be an informal video or a podcast, so pwedeng mag-record lang kayo ng audio and then upload it in Canvas or give me a link. So I'll send the details later. Sana masaya 'yon. Para meron akong pampagana habang nagche-check, meron akong reactions from you guys. Okay. Okay, this third example, luckily, does what I wanted. Papakita niya kung paano natin makukuha or paano natin mapapagsabay-sabay or gamitin ng hand-in-hand yung mga cases na na-consider natin kanina. So in this particular example, so sketch of the solution again, I want you to write a more detailed one. So the sketch of the solution or the solution will start by declaring what's the characteristic equation. So the characteristic equation is m squared plus 9 quantity squared equals 0. All right. So that means meron siyang 2 dito. So ibig sabihin si m squared plus 9 ay twice na factor ng characteristic polynomial. So maybe we can take note of that. So m squared plus 9 or m squared plus 9 is twice a factor of the characteristic polynomial. So ibig sabihin, yung mga roots ni m squared plus 9 has multiplicity 2. Kasi merong exponent na 2 yung m squared plus 9 dun sa characteristic polynomial. So lahat ng roots ni m squared plus 9 ay magkakaroon ng multiplicity 2. So siya ay repeated root. So papasok tayo dun sa case number 2. Pero i-apply natin yon sa mga roots ni m squared plus 9. Pero ano yung mga roots ni m squared plus 9? Note that m squared plus 9 equal to 0 has the solution m squared equals negative 9. So that means m is plus or minus square root ng negative 9. But the square root of negative 9 is 3i. Alright? So, ang ating characteristic ang ating roots ay plus or minus 3i, both of which are of multiplicity 2. Kasi nga meron kang exponent na 2 rito, so twice mag-a-appear si 3i at twice din mag-a-appear si negative 3i as a factor or as a root of your characteristic polynomial. Right? And then moreover, dahil ito ay repeated root of multiplicity 2, so ibig sabihin meron tayong polynomial multiplier dun sa ating solution, right? So the general solution to the GLDE is y equals, yun munang polynomial factor. Kasi yung mga roots natin ay multiplicity 2, pag-iwalayin ko ba or pagsabayan? Hindi, ganito na lang gagawin ko. So, dahil si 3i ay root of multiplicity 2, so ibig sabihin yung kanyang solution ay magkakaroon ng linear factor, right? Kasi siya ay quadratic, si 3i ay twice na root or multiplicity 2 siya. Sabi ng case number 2, kapag ka multiplicity 2, dapat meron siyang linear factor, all right? 1 degree less than the multiplicity. So here we will have C1 plus C2x. Tapos, ito ay para sa root na 3i. Para kay 3i, meron tayong, actually, pwede ko na pala itong pagsabayin, times e to the ax, alright? So, e to the ax, ang e natin dito ay, anong e natin dito? Oh, ang e natin dito ay 0. Ang a natin ay 0. Kasi plus or minus 3i, so that means a is equal to 0, b is equal to 3, right? So, ibig sabihin, magkakaroon tayo ng e to the 0x times a cosine, a cosine 3x plus b sine 3x. So, ito yung ating solution. Hold on, guys. Medyo nagloloko yung aking pencil. Hold on. Give me one moment. All right, sorry about that. I hope my pencil will be working better now. Any questions so far? Does the solution make sense? Okay, I hope it does, right? And then you will see here that we have 4 indeterminates or 4 unknown constants, C1, C2, and then A and capital B. So it's important that you retain those 4 unknown coefficients. All right? Kasi nga general solution to when you look for a particular solution or if you have an initial condition or boundary conditions in your problem, then that's the only time you're going to get the exact values of C1, C2, capital A, and capital B. Okay? So let's see what's the next example here. I think the next example will work backwards. And this will play an important role when you go to chapter 3.6. Kasi ngayon, alam natin yung roots ng auxiliary equation. Okay? So kapag meron ka daw auxiliary equation, ito yung mga solution na makukuha mo para dun sa auxiliary equation na yon. The challenge is, can we find a differential equation na can we find the general solution dun sa differential equation na ito ang roots ng auxiliary polynomial? Okay? So without even knowing how the general linear differential equation looks like, kaya natin siyang makuha or kaya natin makuha yung solution by just looking at what are the solutions of the auxiliary polynomial. So meron ka ng auxiliary polynomial, pwedeng roots na lang yung ibigay sa'yo, so you should be able to find what's the general solution. All right. In this particular case, ito yung mga solutions niya. Let's just see paano sila nakuha. Una, C1. C1 ay simple root. Ibig sabihin, multiplicity 1 siya. So case number 1 will apply to this guy. So ang solution corresponding to the root 1 ay C1 e to the 1x. Kaya ka meron doon. Okay? And then, let's go to the next solution, 2. 2 is of multiplicity 2. So, ang gagawin ko lang, ano yung solution? So, papasok siya sa case number 2. Multiplicity 2 yan, so dapat meron akong linear factor. Alright, kasi ganun, pagka may multiplicity ka, meron ka dapat polynomial multiplier of degree 1 less than the multiplicity. Multiplicity 2, minus 1, so dapat meron akong degree 1 na polynomial multiplier. So, that's how we got C2 plus C3x. Tapos e to the power root x. Ang root niya ay 2, so magkakaroon ka ng e to the x. So that's our solution. And then, by the way, what we do is to get the solution of the solutions. Kasi nga, remember, kapag pag meron kang dalawang solutions sa isang homogeneous differential equation, yung sum nila ay solutions pa rin. Yun yung tinatawag natin na superposition principle. All right? And then the next root of interest would be 4 plus or minus 3i. This is a complex root. So that means, or actually, hindi lang pala, basta 4 plus or minus 3i. Yeah, 4 plus or minus 3i is a root of multiplicity. Parang kulang. Tama ba to? Yeah, it's a root of multiplicity 2. Kasi naulit siya. So dahil root of multiplicity 2 yan, so magkakaroon tayo ng linear factor para dun sa corresponding kanilang corresponding solutions. So meron kang linear factor dito, C4 plus C5x. Pinaghiwalay niya tapos pinactor out niya kasi dun sa form natin kanina, kapag meron kang repeated roots, kung susundin ko yung solution scheme ko kanina, nakita ko ito ay multiplicity 2, so magkakaroon ng C1 plus C2x times, okay, e to the real part, so e to the 4x times arbitrary constant, cosine ng imaginary part, plus b sine ng imaginary part. So ganito ko sinulat yung solution before, but I guess in this slide, ang ginawa niya, dinistribute niya, minultiply niya ito out, dinistribute niya dun sa loob ng sine at saka cosine. Alright? Pero dahil meron ditong arbitrary constant a, so yung multiplier dun sa first factor ay AC1 plus AC2 x times e to the 4x times cosine 3x. Tapos pag dinistribute ko naman to sa second term, BC1 plus BC2x. So magkaiba silang constants. Magkaiba yung constant para sa polynomial dito at sa polynomial dito. Alright? Kasi ang coefficients, pag in-expand ko to at saka ito, ang coefficient ay AC1 plus AC2 at saka AC2. Pero pag ito yung in-expand ko, magkakaroon ako ng BC1 plus BC2x. So magkaiba sila ng constants. Ang ginawa nung slide, pinaghiwalay nyo na lang, tapos yung AC1 binigyan nyo ng ibang pangalan, yung AC2 binigyan nyo ng ibang pangalan, as well as BC1 and BC2. Kaya ang ginawa niya, ganito. So yung linear factor times e to the real part times cosine of the imaginary part plus yung linear factor with different coefficients. So tingnan nyo, C4, C5 dito, pero dito C6 at saka C7, that's fine kasi nga na-distribute si A at na-distribute si B. So magkakaroon ka ng apat na magkakaibang constants para dun sa linear factor. Okay? So C6 plus C7 e to the real part times sine ng imaginary part. So itong dalawang terms na to, siya yung solution corresponding dito sa complex root of multiplicity 2. And then finally, para sa 5 plus 2i, it's a simple root pero complex conjugate pair sila. So magkakaroon tayo ng constant times e to the real part. 5, get that there. Then you'll get the 5 over there. Okay? Times cosine ng imaginary part plus sine ng imaginary part. Okay? So essentially, yung differential equation na problema natin, nag-boil down lang talaga sa pagkuha ng roots ng auxiliary polynomial at pagta-translate ng mga roots na yon into the functional solutions. All good? Ganito sana yung papagawa ko nung midterm exam. Kaya lang in-anticipate ko na hindi natin maabot. Ang saya sana kung bigyan ko kayo ng multiplicity 5, multiplicity 4 na mga complex. So ang haba-haba ng solution. Pero lucky for you guys, hindi ko siya natapos. So napadali yun nandun sa midterm exam. Okay? So that's it. You can try and do some practice here, pero sabi ko nga, reaction video yung susunod na homework. So try this at your own leisure in preparation possibly for the final exam, if you will take the final exam. But yeah, the next few slides will tell us or will illustrate how do we now work the process in reverse. Halimbawa, alam ko na yung solution. Kailangan kong humanap ng differential equation kung saan solution yung given functions. Now, this will be important because you will see later in section 3.6, medyo kailangan ko mag-work backwards whenever working with non-homogeneous differential equations. Okay? So kaya ito, magandang practice to nung gagawin natin mamaya. Given yung isang particular solution, so this is a particular or a specific solution of our GLDE or of our homogeneous GLDE. Gusto nating mahanap ano yung GLDE of the minimum order that will give us this as a particular solution. Or ano yung GLDE na homogeneous na may pinakamaliit na order kung saan solution ang 4e to the 2x plus 3e to the negative x. Okay? So you can analyze the solution by inspection and see what happens. So pabaliktad to ng ginagawa natin kanina. So look at this. So I have 4e to the 2x. So we can forget about the constants because remember, dun sa mga solutions natin from case 1 to case 2, yung mga constant multipliers, sila ay arbitrary parameters. All right? So you can forget the 4 and the 3 here will not play any role in the solution. Sila yung C1 at saka yung C2 dun sa linear combination. So they don't matter in finding the GLDE kung saan solution itong y na to. So you can forget about them. Look at the functions involved. First, e to the 2x. Kailan nga tayo nagkakaroon ng e to the 2x na solution? Sige nga. So maybe I can say here by inspection. We note that m equals 2 is a solution to the characteristic equation. Tama? Kasi remember, nagkakaroon tayo ng e to the ax or C1 e to the ax kapag ka si A ay solution, ay simple root dun sa ating characteristic polynomial, right? Or maybe I can say that a little better here. This is a simple root, When we say simple root, root siya of multiplicity 1. So it's a simple root to the characteristic polynomial. Okay? Also, we got e to the negative x here. Nagkakaroon tayo ng e to the negative x sa solution kapag kasi negative 1 ay simple root din ng characteristic polynomial. So that means here, si negative 1 dapat isingit ko rin. Kasi si negative 1 ay root din na simple ng ating characteristic polynomial. So, ibig sabihin, yung itsura ng characteristic polynomial natin ay, so that means this, the characteristic polynomial of least degree is m minus 2 times m plus 1, right? Alam ko ito yung characteristic polynomial kasi dapat from how the equation looks like, dapat si m equals 2 at saka si m equals -1 ay solution ng characteristic polynomial equal to 0. You can use the factor theorem or just common sense na, si 2 dapat ay maging root. So dapat si m minus 2 ay factor ng characteristic polynomial para pag nag-plug in ka dyan ng 2, magzi-0. Alright? Ganun din si -1. Alam ko si m plus 1 ay factor kasi sabi ng factor theorem, kapag kasi -1 ay root, ang m minus -1, which is m plus 1, ay factor ng characteristic polynomial. Or again, common sense, magzi-0 yung polynomial kapag ka nag-plug in ako ng -1, kaya dapat m plus 1 yung factor. Right? And then dahil ang hinahanap natin ay GLDE, homogeneous GLDE, so kailangang i-translate nyo ngayon yung characteristic polynomial papunta dun sa differential operator. So that means our differential operator is what? Is d minus 2 applied to d plus 1 that was applied to y equal to 0. Yan yung hinahanap natin na differential equation. Or if you want to put it in expanded form, you can write it as d squared what? Minus 2m plus m minus d, tama ba? Minus 2 applied to y equal to 0. Alright? So yan yung differential equation na homogeneous na may pinakamaliit na order such that this is a solution to this. So you can check your solution if you have lots of times and you are doubting your answer. Replace y by this function. Kunin, i-apply mo to, dapat 0 yung maging solution. Okay? But this is just reverse engineering the process that we have established in the first 45 slides of this presentation. Okay? Kaya ba? Pero wait kayo kapag masyado ng komplikado yung solution, so medyo magiging tedious yung pagta-translate back. So let's take a look at another one. So we have 7 minus 2x plus 3 e to the 4x. So again, titingnan natin ngayon para sa ang solution yung bawat term. Right? So pwedeng tingnan mo yung, pagsabayin mo na itong polynomial na to, yung pag-consider sa polynomial na yan. So because superposition principle, right? Yung mga summation dito magbibigay sa atin ng factor dun sa ating differential operator equation. So kailan tayo nagkaka-solution na 7 minus 2x? Pwede mo siyang i-analyze na 7 muna, tapos negative 2x muna. So pero dito pagsasabayin ko na. And then here I'm just showing a sketch of the solution for brevity of discussion. Okay? So ano yung differential equation na homogeneous na solution ng 7 minus 2x? Sige nga. Or ano dapat si operator f such that f applied to 7 minus 2x will be equal to 0? Ano yung differential operator f na pag in-apply ko kay 7 minus 2x, ang sagot ay 0? Sige nga, anyone? So pwede niyong isipin si capital F ay isang instruction to differentiate. So ano dapat klaseng instruction to differentiate yung kailangan kong gawin kay 7 minus 2x para maging 0 yung sagot? Anong klaseng differentiation? O paano ko i-differentiate si 7 minus 2x para maging 0 yung sagot? Partial? Hindi partial. Mas simple sa partial, Victor. Kasi walang partial dito kasi isa lang yung variable, x lang yung variable. So kailan tayo nagkakaroon ng linear solution sa isang differential equation? Or sa isang homogeneous differential equation? May repeated roots? Well, partly correct, pero probably napaghalo mo siguro, Kiefer. Kapag meron kang repeated roots, meron kang polynomial of degree k minus 1, pero may multiplier ka na e to the mx, where where m is a root of multiplicity k. Ito yung lumalabas kapag may repeated roots. Pero kasi dito yung 7 minus 2x, wala siyang multiplier na e to the mx. So hindi siya yung repeated roots. Jen Rensis, can you further specify that? I'm guessing you are on the right track, pero ano yung exact term? Paano ko dapat i-differentiate si 7 minus 2x para ang sagot ay 0? Siguro masyadong nag-overthink na naman kayo, ano? Kailan nagzi-zero ang derivative ng isang linear function? Oh, yun na lang, giveaway na. Would you agree? Constant? Kapag constant? Paano magiging constant? Ano na nga, linear function na. Derivative ng linear function ay 0. So paano ko din-differentiate yung linear function? Yeah, Victor is correct. Nag-differentiate ako twice. Dinifferentiate twice ko yung linear function, kaya magiging sagot ay 0. So yung differential operator dito na d ay d squared, na f ay d squared actually. Right? Kasi kailangan kong i-differentiate twice si 7 minus 2x para ang sagot ay maging equal kay 0. Okay? Or in other words, yung 7 minus 2x, nanggaling siya, or meron kang 7 minus 2x dun sa solution kasi meron kang d squared y equals 0. Okay? Si 7 minus 2x ay solution ng d squared y equal kay 0. Is that good? Nag-overthink kayo, no? So meron ako linear function, so ang operator para sa kanya ay d to the power k. Actually, pwedeng mas mataas. Kasi pag kinuha mo yung third derivative ng 7 minus 2x, magzi-0 pa rin yun. Kinuha mo yung fourth derivative, magzi-0 pa rin yun. Pero ang instruction sa atin dito ay find the general linear differential equation of the least order. So, pinakamababang order dapat ng derivative. So, the lesson here is kapag meron kang polynomial of degree k doon sa yung solution, ibig sabihin, meron kang order k plus 1 na derivative dun sa operator. Okay? So that means here, meron tayong y. So meron tayong kagad d squared dun sa ating equation. So ito na yung partial equation that we have. Kasi pag meron ka ng d squared y equals 0, saka tayo nagkaroon ng 7 minus 2x. Pero hindi lang yun yung problem. Meron pa tayong solution na plus 3e to the 4x. So, kailan tayo nagkakaroon ng solution ng itsura ay 3e to the 4x? Or as I've mentioned kanina, pwede nyo nang i-set aside yung constant. Ano yung ibig sabihin ng e to the 4x dun sa solution? Yeah, John Rensis is correct. Ibig sabihin, meron tayong m equals 4 na solution sa characteristic polynomial. Pero dahil nag-iisa lang to, simple na e to the 4x yung meron tayo. So alam natin si 4 ay root ng characteristic polynomial na simple. Crucial yung sabihin na siya ay simple. Right? So ibig sabihin, meron tayong m minus 4 na factor ng characteristic polynomial. Pero ito ay simple, right? Kasi si 4 ay simple root. So meron ako ditong d minus 4 dun sa differential equation. Okay? So I can expand this as d cubed minus 4d squared applied to y equal kay 0. Ito yung final answer. There are two ways to check this. So you can plug this y into this guy and see if you will get a 0 after simplification. That's one way. Or another way is apply nyo yung case 1 at saka case 2 natin kanina. Alright? So, apply nyo pala si case 1, tapos meron kang d squared y, dun mo makukuha yung constant. Okay? So usually this is just by inspection and then building up the solution as you go along. Crucial to dun sa chapter 3.6, kaya I want to discuss this in details, okay? Now, any questions before we go to the more complicated example? Or okay pa ba? Nakakasunod pa? I hope you are. Okay. So wag mahihiyang magtanong pag hindi clear. Okay. Ito ay medyo kakaiba, alright? Kasi meron tayong 2e to the x cosine 3x. So you can forget about the constant, set it aside. So because ito yung mga C1, C2 na nag-appear. So kailan tayo, sige, kailan tayo nagkakaroon ng solution na e to the x times cosine 3x yung itsura? May exponential na, may trigonometric pa. So kailan tayo naka-encounter ng ganitong itsura? Not exactly this form, pero ganito yung itsura. Ganito yung general feature of all the cases that we considered earlier. Yeah, Billy James is right. Nakita natin to nung may complex roots. Pero ano yung pinagkaiba niya? Nakita natin pag complex roots, dapat merong sign na kasama. Sir, bakit cosine lang yan? Eh di mag-imbento ako ng cosine. Pwede ko itong i-imagine as plus 0 times e to the x sine ng 3x, right? So ito yung D1, ito yung D2 ko. Or ito yung capital A ko, ito yung capital B ko. Right? So ito yung dalawang arbitrary constant. Tapos kamukhang-kamukha na siya nung ating case number 3 o nung resulta ng case number 3. Agree? Dapat parehas yung exponential. Tama kasi nga fina-factor out ko to pag ako mismo yung nagsulat ng solution. Tapos cosine at saka sine. So kung ganito yung general itsura ng solution, what is the root? Or what are the complex roots? The complex conjugate pair roots of our characteristic polynomial. M equals what? Dali bang isulat sa chat or hindi? Aha. Medyo may problema, John Rancis, dun sa answer mo. Yeah. Nakita naman ni John Rancis. Okay. So thank you, ang bilis ng chat. Justin, John Rancis, Syra, Crisel, Kiefer, Billy James, and Justin. Tama. So ibig sabihin si 1 plus or minus 3i ay root ng ating characteristic polynomial. Saan nanggaling si 1? Si 1, yung real part, siya yung multiplier sa exponent. Kaya tayo nagka-1 doon kasi 1x yung exponent ni e. Tapos yung 3, nanggaling siya dun sa multiplier dun sa loob ni cosine, siya yung imaginary part. Then just don't forget the complex imaginary unit. Okay? So, ibig sabihin, ang characteristic polynomial natin, ang itsura ay m minus 1 plus 3i at saka m minus 1 minus 3i. Ito yung ating characteristic polynomial of the least degree. Tapos, nakalimutan ko yung shortcut sa pag-multiply ng complex numbers. Ano? So, mamanu-manuhin ko muna ito para makuha ko yung expanded form ng ating solution. Pero pwede nyo dayain, pwedeng sabihin nyo, ito na sir ito na yung differential equation. Okay. And you would have been right. So this is a differential equation na solution itong 2e to the x times cosine 3x. Though hindi to magandang tingnan kasi may complex numbers. We want to avoid complex numbers in how we present our solution as much as possible kasi nga usually real coefficients lang yung gusto nating makita. So kailangan ko lang itong expand, but essentially since they are, or the subtrahends here are complex conjugates, so magsisimplify nicely yung product. So siguro i-multiply ko lang to. Tanda ko ba yun, no? Tanda ko ba yung shortcut? Pwede kong i-derive yung shortcut. Or wag na lang. Sige na nga, if-foil method ko na lang. So ito, if-foil method ko, medyo magulo yung board work ko kasi nga sabi ko, Kayo na yung bahalang mag-arrange mag-arrange ng solution. Pero pag nag-FOIL method ako dito, magkakaroon ako ng m squared minus 1 minus 3i times m. And so ito, saka doon. Then I'll have minus 1 plus 3i times m. Tapos plus 1 plus 3i times 1 minus 3i. All right. FOIL method, simple FOIL method. Then I'll get their sum. So I'll have m squared. Tapos pareha silang may m. So put down the m. Tapos meron ng negative 1 minus 1. So I'll have a negative 2. Tapos positive 3i minus positive 3i. So that's gonna be 0. So mawawala yung imaginary part. So magkakaroon lang ako ng m squared minus 2m. And then this is a plus b times a minus b. Yan yung itsura niya, right? Tapos alam natin special products. This is a squared minus b squared. So essentially we'll have plus 1 a squared minus b squared, no? So minus 9. Tama ba? A squared minus b squared. So that's 1 minus 3 squared. So 1 minus 9. Okay, that's what I got. That's a constant. And this guy is m squared minus 2m minus 8. Ito yung ating simplified characteristic polynomial. Okay? So ang shortcut pag nagmo-multiply ng complex conjugate pairs ay ito. Sana makuha ko yung shortcut. So kapag ka meron kang m minus z, where z is a complex number, times m minus z bar, which is the complex conjugate, this is m squared minus twice the real part ni z. Kunin mo lang yung real part ni z, multiply mo ng 2, then plus a squared minus b squared. Okay? So ang real part niya ay a nga pala, so ito na yan. Ito yung formula para dun sa product ng complex conjugate. Sa product ng m minus complex conjugates. So pag meron kang m minus z times m minus the complex conjugate, siya ay m squared minus 2a plus a squared minus b squared. Okay? So remember, in our example here, a is 1, b is 3. So m squared minus 2 times a. So magkakaroon ng minus 2m, nawala yung m. Tapos yung constant ay a squared minus b squared. Or you can just do the plain old FOIL method. Medyo hindi ako mahilig sa formula, kaya nag-FOIL method ako. Nang ginawa ko na yung FOIL method, saka ako nakita yung pattern. Ito nga pala yung formula. M squared minus 2am. Sulat ko lang ito ng maayos. Oops. Plus a squared minus b squared. Okay? So therefore, ang final answer, dito na lamang, ay d squared minus 2d plus 8 applied to y ay equal kay 0. Yan yung ating differential equation kung saan solution ang 2 to the x times cosine 3x. Okay? Any questions about this? Plus 10. Bakit magiging plus 10? Oh, yeah. Thank you. Thank you, John Wences and Justin. Yeah, mali yung formula ko. Dapat pala ito ay plus. Oops. Kasi nakalimutan kong isama yung I squared. So magkakaroon nga pala tayo ng 3i times negative 3i. So that's gonna be negative 9i squared. Pero ang I squared ay negative 1. So ito ay magiging positive 9. So this is plus. Thank you. Yeah, tama kayo, Justin and John Wences. This should be a squared plus b squared. So this should have been 10 instead of 8. Plus 10. Then ito ay plus 10. Okay. And again, there are multiple ways on how to double check your answer. Ano? Pwede niyong gawin ulit. Case number 2, mag-quadratic formula kayo katulad nung ginawa natin kanina just to retrace what happened. Okay? Or, yeah, i-plug in nyo yung given solution na y equals 2 e to the x cosine 3x dito sa differential equation na ito. Okay? So aside from the complex arithmetic, any questions? Oh, don't worry, may isang example pa naman. Okay. 3x sine 2x. Saan naman na, ano naman yung solution para dito? Meron akong 3x na naka-multiply kay sine. Pero alam ko pag sine dapat may cosine na kasama at may exponential dapat nakasama. So is there a way that I can write it as a solution of the form one of the given ones tapos with various undetermined constants nga lang. Okay? Now the trick here is alam ko meron kang linear function. Nagiging multiplier yan. So pwede ko itong isulat na or ito yung form niya. Yeah, John Rensis is correct. May nakatago na yung, di ba gusto natin yung exponential, laging may kasamang sine at saka cosine. Well, alam na natin na pwede ako mag-plus cosine lang dito, may multiplier lang na 0, tapos yung nawawala na e to the, nawawala na exponential, pwede kong isulat na e to the 0 as John Rensis suggested. So pwede ko itong isulat pala na merong e to the 0 x. Okay. Tapos yung, hindi ko na pala ito kailangan. Dito ko na lang siya isulat. Tapos ito, pwede ko itong isulat na 0 plus 3x. Alright? So magkakaroon din ako dito ng plus 0 times 0 plus 3x times e to the 0x times cosine 3x. Alright? Si 0 yung arbitrary constant na gusto ko. Gusto ko lang siya mag-0. Tapos ito, kinopya ko lang para ron magkaroon din ng linear multiplier. Okay? Tapos e to the 0x, that is just equal to 1. Tapos cosine 3x, kasi gusto ko kapag ka may cosine, lagi ring may sine. So, anong to? Anong combination of rules? So, ibig sabihin, una, meron tayong complex roots. So, that means m equals what? What's the complex root that we're looking for? Our complex root is... bakit 3x? Dapat ito ay 2x. Kaya siguro kayo nalilito. Ano? So, dapat si 0 plus or minus 2i ay solution. Yeah, thank you, Kiefer, Justin, and Billy James. Okay? So, lagi kang may plus or minus 2i na solution. Kaya lang merong linear multiplier. So, what does that linear multiplier mean? Tells us. That linear multiplier suggests to us that plus or minus 2i is a root of multiplicity 2. Right? Kaya tayo nagkakaroon ng linear multiplier kapag yung ating root ay multiplicity 2. Alright? So that means here, so magkakaroon tayo ng m minus 2i times m minus negative 2i. Tapos saka-square pa yan kasi multiplicity 2 sila dapat. Tapos ito yung naka-equal kay 0. Ito yung ating characteristic equation. So m minus the roots, tapos multiplicity 2. Then carry out the multiplication here. So we'll have m squared. Tapos meron ba akong m terms? Twice, okay, wala akong m term. Tapos ito ay magkakaroon na lang ako ng plus 4. Quantity squared equal kay 0. If you perform this multiplication, you get m squared plus 4 quantity squared, right? And that's easy kasi ang m squared plus 4 equal kay 0, mangyayari lang yan kapag si m squared ay negative 4. So that means m equals plus or minus 2i. Okay, so this is our characteristic equation, which translates to the following GLDE. na homogeneous. So ito ay d squared plus 4 quantity squared applied to y equal kay 0. Ito yung homogeneous GLDE of the minimum order kung saan solution ang 3x sine 2x. Okay, so I hope this is making sense. Medyo minsan mas mahirap nga lang yung pabaliktad kasi yung last session natin, ginugol natin pagko-compute ng forward problem. Ngayon, inverse problem naman yung sinusolve natin. So simula sa solution, nagwo-work backwards tayo para mahanap ano yung problem na sinolve para makuha si 3x sine 2x. And you might think this is just a theoretical exercise, pero hindi. Kasi kailangan natin to sa chapter 3.6 pag nagsosolve na tayo ng non-homogeneous general linear differential equation. Okay? So let me see what else is in the slides. Yeah, siguro let's finish this up kasi ito na naman yung last example. So it doesn't hurt to work another one. So ngayon, tingnan nyo ano yung mga sums, ano yung mga building blocks dun sa solution. Well, the first building block is this this quadratic polynomial. So para saan naging solution itong quadratic equation na yan? So meron akong y, equate ko kay 0. Unahin ko to kasi madali to eh. So ano yung differential operator para magkaroon ng solution na 4 plus 2x squared? Kakaiba to dun sa kanina, balikan ko lang, kasi dun sa kanina, naka-multiply si 3x dun sa sign. Dito rin, sorry, yeah. Wala na palang ibang example, no? So, but essentially, you have the linear function multiplied to sign. Dito naman, meron kang quadratic pero naka-add sa exponential. So, ibig sabihin, 4 plus 2x squared will get a different differential operator. So, ano yung differential operator? Kung saan solution si 4 plus 2x squared? Of course, of the minimum order. Ano dapat yung differential operator dito para maging 0 yung sagot? D to the third, sabi ni John Rensis. Yeah, that's correct. Because kailangan nating kumuha ng third derivative parang isang quadratic polynomial ay mag-0, right? And you can double check. 4 plus 2x squared, ipalit mo siya as the y here, the third derivative will be equal to 0. Of course, you could have chosen d to the fourth, d to the fifth, d to the sixth. Those derivatives will again bring us 0 as an answer when we plug in 4 plus 2x squared. Pero ang instruction sa problem na to, I get the general linear differential operator of the least order. So kailangan pinakamababa. We know the third derivative of 4 plus 2x squared is equal to 0, but the second derivative is not equal to 0, so hindi pwede yung second derivative. So ibig sabihin, third derivative na talaga yung minimum na pwede natin gawing differential operator. Okay? Tapos, saka magdadagdag na lang ako dito ng isa pang operator. Yung operator naman na magbibigay sa atin ng solution na 3e to the negative 3x. Ito, dapat mas madali to. Yung negative 3, we can chalk it up to the arbitrary constant. So nagkaroon lang tayo ng solution na e to the mx. Tapos nag-iisa lang siya kasi walang mga nakahalong linear operator, linear polynomial, walang polynomial of some degree, wala ring sines and cosines na involved. So ano yung differential operator na makukuha natin sa e to the negative 3x? So ano yung isusulat ko dapat dito? So ano yung ibig sabihin? Kailan tayo nagkakaroon ng e to the negative 3x sa solution? We are getting e to the negative 3x in our solutions when m equals negative 3 is a solution to the GLDE. To the characteristic equation. All right? At tama si Kiefer at saka si John Rensis na d plus 3 yung ilalagay ko. Kasi pag convert ko yung d plus 3 sa characteristic polynomial, magiging m plus 3. Ang solution ng m plus 3 equals 0 ay negative 3. Simple root. Kaya nagkaroon ng constant times e to the negative 3x. So therefore, the solution here that we're looking for is d to the fourth plus 3d cubed applied to y equal to 0. Okay, so I just you guys play with these examples or these exercises just for you to get the hang of it. Kasi kailangan mabilisan yung makuha yung mga homogeneous GLDEs of the minimum order para makuha yung GLDE na sinusolve ng particular equation kasi kailangan natin yan sa section 3.6. Just a quick typo here, hindi to degree, dapat order. Order yung ginagamit natin na term. Although in most cases, ini-interchange. Nagiging careless ang mga mathematician sa paggamit ng order at saka degree. Alright? Pero by our definition, dapat order yung gagamitin natin. Yung order ng GLDE, siya yung degree ng characteristic polynomial. So kaya siguro napagbaliktad nung slides, yung degree at saka order. Okay? And I think finally, yes, that's the end of chapter 3.5 or section 3.5, which leaves me only with 9 more minutes. Kaya pa ba nating simulan yung next set of slides? Siguro intro na lang. Okay. Itong susunod ay pagsosolve naman ng mga non-homogeneous linear differential equations. So dun sa section 3.5, sinosolve natin yung operator A applied to y equal to 0, where A is a linear differential operator. Okay. Ngayon, ano yung mangyayari kapag hindi na homogeneous yung differential equation? Meaning, meron tayong r of x dun sa right-hand side, where r of x is not identically 0 over the entire interval. So mas komplikado yung solution kapag hindi 0 yung right-hand side. Kaya in applications or in practice, lagi namin kino-convert yung non-homogeneous differential equation to a homogeneous differential equation kasi masyadong matrabaho yung pagsosolve ng non-homogeneous GLDE. Kasi kung makikita nyo or kung maalala nyo from section, I think it's 3.2, meron tayong remark na kapag meron kang non-homogeneous linear differential equation, ang itsura ng solution niya ay y sub c plus y sub p. Si y sub c, ito yung solution dun sa homogeneous GLDE. So ibig sabihin pala, kahit non-homogeneous, yung GLDE natin, ang first step sa pagsasolve ng equation 1 na to, dapat humanap muna tayo or hanapin natin yung general solution dun sa homogeneous GLDE. So basically, isosolve natin ito ala section 3.5, we will assume that the right-hand side is 0 for the moment muna. We forget about r of x muna, tapos isosolve natin yung GLDE. So babalik tayo sa chapter 3.5 kapag non-homogeneous yung DE. So sa pre-final exam, expect na hindi na ako magbibigay ng isang homogeneous GLDE. Kasi pag nagbigay ako ng non-homogeneous GLDE, kakibat nun yung pagsosolve ng homogeneous GLDE. Right? Kasi yun yung first step. Kailangan hanapin mo muna si y sub c. Ano si y sub b? Siya ay isang particular solution of equation 1. Remember, ang hinahanap natin ay general solution. We're looking for a general formula for all possible solutions of equation 1. Ang sabi ng slide na to, ang general solution na yon ay general solution ng homogeneous GLDE plus one specific solution of the non-homogeneous linear differential equation. So kailangan, after mo mahanap yung general solution ng homogeneous GLDE, kailangan makachamba ka at makahanap ka ng at least isang specific solution ng equation 1. I-add mo yon dun sa general solution ng homogeneous GLDE, you get the general solution for the non-homogeneous GLDE. And I guess I already explained why this occurs. in section 3.2 or section 3.3. So just go back there kung bakit nga ba ganito yung itsura ng solution. Okay? But essentially, that's it. So in section 3.5, we learned how to find the general solution of the homogeneous GLDE given in equation number 2. So magfo-focus tayo ngayon kung paano mag-solve ng particular solution. Para ma-assemble natin yung general solution doon sa equation 1, which is a non-homogeneous GLDE. Okay. Now, here's the general method, or this is the general recipe for the solution. At as I mentioned kanina, ang unang step talaga, balik ka sa chapter 3.1. I-solve mo yung homogeneous differential equation. So, kukunin mo yung auxiliary equation, tapos isosolve mo yung roots ng auxiliary equation, tapos i-assemble mo yung solution depende dun sa itsura ng roots ng characteristic polynomial. Then set it aside because that will be the first term in our general solution later. Tapos yung second, the next steps is geared towards finding a particular solution nito. Kailangan ko makakuha ng isang specific solution ng f of dy equals r of x. Now, paano natin siya gagawin? Ganito, medyo komplikado ito. So, una, humanap ka muna ng homogeneous linear differential equation na si r ay particular solution. So, gagawin natin dito yung ginawa natin towards the end of the previous set of slides. Yung kagagawa lang natin. So, kailangan kang humanap ng homogeneous GLDE na solution si R. So si R yung gusto mong solution, kailangan humanap tayo ng GLDE ng itsura ay G of D applied to Y ay equal kay 0. So essentially, gagawin natin yung ginawa natin kanina, dun sa mga examples kanina. Alam ko yung solution. Ang solution ay R of X. Gusto ko ngayon kumuha ng isang homogeneous GLDE na solution yung R of X. So si G of D, ito yung mga nakukuha natin na solution kanina dun sa mga exercises natin. Tapos, pag nahanap mo na si G, gagawin mo naman, hanapin mo yung general solution nito. General solution ng G of D applied to F of D applied to Y. Bakit? Kasi alam na natin na si F of dy alam na natin ay equal kay, general solution nga pala yung hinahanap ko, no? So, ibig sabihin, G of D applied to 0 should give us F of D equals R. Okay? Ulitin ko yun. Bakit ganun yung nangyari? You can think of it as G of something. G of Z equals 0. And by design, we know that R is a particular solution of G of D applied to Y equal kay 0. So, ibig sabihin, si G of DZ equals 0, meaning Z is equal to R. Right? Kasi ganun natin pinili si G. Ganun natin din-assign si G. Ang G of, ang R ay particular solution ni G of D applied to Y. So, if I have this G of Z, G of D applied to Z equal to kay 0, so ibig sabihin by design, by purpose, ang Z ay equal kay 0. Alright? So, ibig sabihin lang nito, pero ano nga ba si Z? Si Z ay tinago ko lang na F of D equals Y. So, ibig sabihin, si F of D applied to Y, which is our Z, tinago ko kanina sa pangalan na Z, so dapat si G of D of Y, which is our Z, dapat equal siya kay R, which is basically what we wanted to solve. Okay? Now, medyo mano yung proseso, pero this will become clearer when we look at a particular example. Okay. Step number 4, delete from the solution obtained in step 3 the part which is already in y sub c to obtain y sub p. Gusto ko lang kasi particular solution. So, kukunin ko tong solution na to, isosolve ko kasi to, I will get a general solution, but I know R is a particular solution. Okay? So, pero magkakaroon ng overlap yung solution. Magkakaroon ng overlap yung solution dito dun sa solution y sub c. So ang gagawin ko lang, buburahin ko lang dun sa mga solutions nito yung nandun na sa y sub c para walang repetition. Okay? Just to make things simpler. That's what step number 4 is telling us. Tapos, after step number 4, isa-substitute ko ngayon si y sub p dito. So gagawin ko, i-apply ko si f capital D kay y sub p, kukunin ko yung expanded form. Okay? Simplify ko yan. Tapos i-compare ko to kay r of x. Kasi remember, yung nakuha natin sa step number 4 is a general solution. Kasi dun sa step number 3, ang gusto natin humanap ng general solution. So may mga arbitrary constants dito. May mga arbitrary constants dun sa solution na makukuha natin. I-delete ko lang mula dun sa may mga arbitrary constants, yung na kay y sub c na. So essentially, what we get here as f of d applied to y ay magkakaroon ng mga arbitrary constants. Pero ang gagawin ko lang para mawala yung mga arbitrary constants, titingnan ko ngayon, i-compare ko si y sub p kay r of x para makuha natin yung arbitrary constant. Okay? Now, it seems to be a lot of mumbo jumbo there, pero siguro it would be easier to look at a particular example, though it's already time. So siguro next time, mag-start tayo sa slide number 7. Okay? Medyo hindi ko to imamano-mano lahat kasi if you will see this, maraming sinusulat. So explain ko na lang step by step. I'll try to do hand solutions whenever possible. Pero ano lang to, marami kasing sinusulat. Sa gusto kong makita nyo step by step or side by side with the steps in the recipe with what I am doing para makita natin yung general flow. Right? Pero yun yung basically, yun yung 5 steps na kailangan natin gawin to solve a non-homogeneous GLDE. At talagang mas matrabaho mag-solve ng non-homogeneous GLDE kaysa sa isang homogeneous GLDE. Yun yung gagawin natin on Friday. Okay? Any questions? Medyo nabudol niyo ako kasi ang plano ko mag-start dito sa dapat matapos ko yung slide set na to pero diniscuss natin yung natira sa section 3.5 which is okay din naman because since we have a good understanding of the last portion of 3.5 magiging mas madali sa atin hopefully yung step number 2. Kasi after step number 2, alright, so yung step 1 alam niyo na from section 3.5. Yung step number 2 siya yung nasa dulo ng section 3.5 na ginawa natin kanina. Steps 3, 4, and 5 ay purely algebraic and elementary calculus. So, yeah, yun yung titingnan natin how this entire recipe comes together when for particular GLDEs. Pero may limitation itong method na to. Alright? Yung method na to ay nag-work lang sa specific R of X's. Kasi look at step number 2. Kailangan ko mag-imbento ng homogeneous GLDE na particular solution si R. Paano kapag si R ay hindi lamang exponentials, hindi lamang siya polynomials, hindi lang siya polynomial times exponential times trigonometric, paano pag napaka-komplikado ni R? Halimbawa, meron siyang ln, meron siyang hyperbolic cosine, meron siyang mga inverse trigonometric, and so on. So, hindi natin magagawa yung step number 2 kasi napakalimitado ng ating capability to carry out step number 2, specifically for nice functions R na na-discuss natin before. Na meron kang exponential, meron kang trigonometric. When I say trigonometric, meron kang sines and cosines. Tapos meron kang what? Meron kang polynomials or polynomial times exponential times sine and cosines. So, doon tayo magiging limitado. Kapag si R ay may mga functions other than those guys, then kailangan nating maghanap ng ibang methods. Alright? Pero we'll be contented with what we can do right now, and we'll start with example number 1 next meeting on Friday. Okay? So any questions, guys? Medyo paiba-iba, isa pa ko pa pala napansin before we part ways, ano, nakakalito nga yung deadline ng ating mga homework. So, gusto niyo ba mag-decide na once and for all na 11:59 na lang? Anong gusto niyong deadline? 11:59 PM ng, sige, gawin nating Tuesday o 9:59 AM ng Tuesday? Ano yung mas convenient sa inyo? Para hindi kayo nasasaraduhan ng submission bin. Sige, pag homework na lang, gawin nating ano, usually 1 week tapos 11:59 PM. So pag binigay ko ng Wednesday yung homework, ang deadline na lang ay Wednesday 11:59 PM. Alright? Okay lang ba 'yon? Para medyo uniform na hindi na kayo masyadong nalilito dun sa pagko-close ng submission bin. So sige na lang. So yung reaction video sa midterm exam, ano 'yon, seryoso 'yon. Pero hindi kailangan seryoso yung isa-submit niyo. Reaction video or reaction podcast ay ang due ay Wednesday 11:59 PM. Wag naman yung nobela ano, siguro 1 or 2 minutes, at most 3 minutes na ranting, okay na yon ano. Wag niyo nang gawing 5 minutes o isang buong podcast episode ano. Hindi naman tayo kikita sa Spotify dun sa mahabang ano, sa mahabang podcast or sa YouTube sa mahabang video. So I just want to see how you felt ano dun sa midterm exam. Okay, other questions, concerns? So kung wala na, thank you guys. Enjoy the rest of the day. Let's see each other again on Friday. Bye.
Thank you, sir.